Uh, Good afternoon, ladies and gentlemen, and welcome to the fourth installment of our easyPH series of webinars on um, modeling buildings using the easyPH approach within PHPP. We apologize that we had to cancel the webinar on the 29th of July, and unfortunately we've had some further technical difficulties today, so we've decided to record the webinar and issue the link around. So again, we do apologize for that. So today we're going to look at entering heating, cooling, and domestic hot water systems into easyPH. So many of you will be familiar with entering heating systems and domestic hot water. We don't tend to see cooling systems used all that much in this part of the world, but we're going to take a quick look at those and start with the cooling, and then we'll move on to heating and domestic hot water, which are I suppose the more meatier parts of the webinar. So again, I'm very thankful here, Barry, for Dr. Barry McCarran has allowed us to use his dwelling as the guinea pig dwelling. So we're continuing to use that dwelling as our starting point here. So that's the house here, as you can see, and you can see the certification criteria all entered into PHPP on the verification page here. So within the easyPH tab in PHPP, we can enter our cooling using two main approaches. We can use a simplified approach, and we can use a detailed proof of efficiency approach. So for most projects, I think the simplified approach will allow you to get past your certification pretty easily, and then if you have detailed information, then we can look at going the detailed road. So we're going to look today, I suppose, quickly at the cooling section. So within the cooling section, we have a couple of options. We can select different types of cooling units here. So we have three main types. We have an air-to-air split unit. We have an air-to-water heat pump, which is our more traditional air-to-water that we're all familiar with. And then we have a brine or groundwater system, which is, I suppose, more frequently referred to as geothermal system. And it can use a mix of horizontal or vertical source pipes. So that doesn't make any difference. We're really interested in the source here, which is brine. So that's what we'll select from one of those three options. We then have to select our cooling type. So we have three main cooling types here. We have supply air cooling, which is our cooling via our supply air, which has a very limited output. Using supply air, we can only cool the air so much before we actually hit the limit of how many watts per meter squared we can get into the building. We tend to see majority of cooling done via recirculation cooling, which is your more traditional fan coil unit. They can be supplied by water, refrigerant. There's some hybrid approaches out there as well, where they use a mixture of refrigerant and water. They're fine as well for those systems. And lastly, we have panel cooling then, which I suppose is your traditional air to water pipe work, or sorry, your underfloor heating pipe work being used as the medium for providing cooling, or radiant panels or chilled ceiling panels on the roof. And sometimes we also see those panels incorporated into walls as well. So they can be installed anywhere for panel cooling. Not that common of an approach in this part of the world. I suppose there's limits with that as well. You can only cool the water so much for those panels before you run the risk of condensation occurring on them and things like that. So they have a limited output. The recirculation cooling gives you by far the biggest output. It wouldn't be unusual to see a mix of these systems. Where that occurs, you would enter in the system that gives you the highest output, which in most cases will be the recirculation approach. So you select one of those approaches. We also have to input whether it's an inverter heat pump. So this would only apply to water-based systems. As you can see here, there's little notes left in PHPP. So that would apply where you're using a traditional air-to-water heat pump. The reality is nowadays nearly all modern heat pumps are inverter systems, so you'll nearly always select the or switch that on in your easyPH tab. There's also an input there for where you have buffer storage available. So it wouldn't be unusual with air to water systems to have maybe a buffer vessel or a volumizer or some kind of a storage vessel where you have that occurring. You can X on for switch that on there as well by just activating the X in the box. So that's all pretty straightforward there. Not too many inputs. It should be usually straightforward to find all that stuff out. And then when we come to inputting the inputs in for our simplified calculation, we put in the manufacturer, we put in the model, and we put in the nominal power. So we'll see there that the nominal power is based on 35-degree outdoor air and 7-degree water. You can use 18 degrees where you're relying on surface or panel cooling. Um, can be inputted there. And we can also see there that there are some additional notes there. It says for multi-split cooling systems, please use the nominal power of the outdoor unit. So that should be straightforward, I think, for most people to gather up that information. So then we have an input here. It asks us to input the SEER of the system, which is the standard, which is the seasonal EER, which is the cooling equivalent of COP. So we take that value from the data sheet provided by the manufacturer, and that must be looked at against EN 14825. So that's the standard that's used. So that value just gets plugged in directly. Where we have a system based in the US, which I think probably will only apply in circumstances where we've any attendees from the US, we can take data from the ANSI or AHRI standards 210, 240, and we can put that value in there if there's a value for that, and that must go in the imperial unit, so it goes in kilo BTUs per kilowatt hour. And that's sometimes referred to as SEER2 is the name on that. So that's the alternative approach. But in European context, we'll always use EN 14825, and all manufacturers will work to that, where they're providing heat pumps onto the European market. So where we have a detailed proof of efficiency, we have various inputs here. We can select, whether it's a split unit or a heat pump according to EN 14825. From the drop-down list, we can then select the unit list, which will come alive if you have filled out the components tab. So the components tab is one of the tabs we have available in easyPH. So where we have a heat pump, we can enter in the heating and cooling information for those heat pumps into that tab, and then use that information within our easyPH tab. We can also put in the number of units we have. So if we've multiple heat pumps, we can put in that we have, 1, 2, whatever, we've 3 of them or something, which, can sometimes occur. You can put in the number of units. The same for recirculation cooling. You can select from the drop down the type of generation system. You can select the unit from the components tab and enter the number of units. And where you have surface cooling, you simply just select the heat pump from the list, and you just leave it at that. There's nothing else to do there. It's assumed where you're using surface cooling that you're always using a water-based system. So therefore you don't have any drop-down option here, because you don't generally get surface cooling with refrigerant-based systems. So that are split type systems, they don't tend to arise. And last but not least, we have a section for additional dehumidification. This rarely, if ever, arises in the context of certainly in Ireland and the UK. This doesn't arise. This would more arise in countries where you have very high humidity levels and you need to do a lot of additional dehumidification to keep the room cool. So you can tend to ignore that for most cases. If there's a case where you need additional dehumidification, then it's a question for your certifier at that point. So that's really the end of it on cooling. I mean, it's quite straightforward. If you can see, it's very easy here. You need your couple of inputs. You need your bit of data from your manufacturer. You can typically get those SEER values from data sheets. You can get them from eco design data. There's various sources. There's just plenty of places to get that information. And you just plug the numbers in, and the model will look after itself from there. So that's as much as we have to say on cooling today. So we're going to go into heating now, which I suppose is more more pressing issue here for passive house buildings. Where seeing as we have a heating dominated climate, certainly in Ireland and the UK and I suppose the wider part of west of Europe, there's nearly always a heating climate. As you get further south, then that becomes a cooling climate. The first thing we have to do is select our heat generator type. So this should be pretty familiar for most people used to modeling in PHPP. So we have a list of options here. We can select a compact unit, which is the combined domestic hot water, heating and ventilation systems. There's various types of those systems on the market. Many you'll be familiar with units like the Neelan Compact P. There's a Genvex unit. There's units by System Air. There's units by Stable Eltron. There's various. There's a whole range of manufacturers there that provide those units. If a unit like that has been installed, you select compact unit. If you're using a more traditional heat pump, you select heat pump, district heating or CHP. If the case arises, not that common in the context of Ireland. A heating boiler, if you're using traditional gas or oil systems, you can enter those. And then if you have direct electricity, which is commonly used in apartments, we often see domestic hot water heat pumps combined with electric space heating in apartments. So you can select that there as well. And you can select up to 4 generator types. So you can actually mix and match your generator types if you have a combination. And you can assign the percentages in the various columns there. Should all be pretty familiar to most people, I think, who are using the PER tab in PHPP. So there's nothing unusual there. So if you're using your compact unit or your exhaust air heat pump type unit, the list of units is already set up in easyPH. So all you have to do is select your unit here from the list. And as you can see the Genvex is there, Neelan, there's a Pickler, Stable Eltron, System Air, there's Tekelor, there's Drexel and Vice there. So there's all those units are available directly from that list. And you literally just drop down, select the unit, and you're pretty much done on the space heating front. I suppose we're going to get into the weeds a little bit more here now, because we're going to begin to look at, I suppose, your more traditional heat pumps, and I suppose there'll be a focus here on air to water. I suppose air to water is the dominant heating system used now, certainly in Ireland and the UK now for providing heating to modern buildings. So I suppose our effort will be focused on this one today. So again, you see there's not that many inputs. We have actually more options than we do when we're looking at cooling. So we can work through the options, pretty easily and see that actually it's quite straightforward to input a heat pump into easyPH. So what you will do first is select your heat pump type. So we can see here that we have some more subtypes of the brine and groundwater heat pump. So we can see where we have a true groundwater heat pump. We can see where we've geothermal probes, then which is your vertical probes. And we can see we have a ground collector where you have the horizontal loop type systems placed in the soil. You also then have your standard air to water heat pump, which we're all familiar with. And then you have your air to air split system then, which is your, VRF, VRV, all these kind of refrigerant based systems fall in under air to air. So you just select from the list there. We're going to focus on air to water today because that's the primary one. So the first thing we do is we put in the number of units that we have. So in most cases, you have a single heat pump. If you have multiple heat pumps, there's no problem with that. Just put in the number of units that you have, and we can model away from there. The next question we have to look at then is the heat pump an inverter heat pump? So the reality here is that most heat pumps are inverter nowadays. There really shouldn't be any heat pumps out there that are still working on a fixed speed compressor. They should all be working on in variable speed or inverter type compressors. So where that's the case, you select the X in the box and proceed. We can also then enter in where we have separate buffer storage. So again, if we have a buffer vessel or a volumizer, We can select whether that vessel is inside or outside the thermal envelope. I would contend it should never be outside the thermal envelope. It would be very wasteful, but it could happen that it's outside the thermal envelope, in which case you select that option. If it's inside the thermal envelope, then select that, and then obviously if you don't have one, no, there's no input there. I suppose it's a little bit important to point out here that if you're looking at a heat pump system that has a built-in domestic hot water cylinder, that will typically not provide buffer storage for your space heating system. So even though you may have a 180 or maybe a 200 liter tank as part of the heat pump system, it does not qualify as buffer storage. Buffer storage is where the water is purely being used just for supplying the heating system to balance out the loads on the heat pump. So there's an important distinction there that we don't fall into that trap of switching on buffer storage when actually we don't really have it, because it will apply a penalty to our calculation, which we don't need. So that's those few inputs. So again, manufacturer, product name, they are what they are here. In this case, Barry installed an EcoAir 1 to 7 Pro is what was installed here. And I actually have the data on file from the certification of the building, and we can actually look at where we extract that data from, for a real live project, and where we actually plug those numbers into PHPP. So I suppose the first question we have to work out is what's the nominal power of the system. So that's the first question that's asked. And again, as you'll see, there's plenty of notes given in PHPP here with guidance for you. So you can see here for air to water heat pumps, it's based on a heat pump in accordance with Directive 813 at -10 and the water temperature at 35 degrees. Okay, so where it's at, that's the value we should be entering for our nominal power. So when we go to the Eco Design data sheet for that heat pump, what we actually see here is that the heat output is given to us here as 3.30 kilowatts. Now some of you are probably saying there, but that's reference to the wrong standard. That the standard requirement there is EN 14825. But actually EN 14511 is part of the EN 14825 standard. So a heat pump that's certified to EN 14511, it would also be ordinarily compliant with EN 14825. So anybody who's working at BERs or anything like that will be, your EPCs or any of this kind of stuff will be well familiar with those standards. We also have a reference here to the EU standard 813, which is the European Union standard for heat pumps, which also happens to be practically the same as EN 14825 for the purposes of the work we're doing. So any of those standards are all interchangeable. There's no real issue with applying any of them. So once a standard is referenced somewhere, in this case we can see here that the applied standards is 14511, 12102, 14825, and 16147, and 16147 being the domestic hot water standard. And the 12102 is the acoustic standard for heat pumps. So we'll be focusing on these three standards and not so much on the acoustic standard. We're not really that interested in that at this point. So we'll input our nominal power, which is given here as 3.3 kilowatts, which is based on the 35-degree heating application. So that value goes in there. And then PHPP gives us three options here. So we can put in the seasonal heating efficiency, we can put in the SCOP, or we can put in the HSPF2. So the HSPF2 is the value that you would use in the US, where you're working in imperial units. So as we've seen with the cooling standard, it works on the ANSI or AHRI standard, the 210, 240. So you get the value from that and you plug that value in. If we're working in Europe, we can use either seasonal heating efficiency or SCOP. So in most cases, you'll get both values. So it really doesn't matter which approach you decide to take. In this case, you'll see I plugged in 175% here for the seasonal heating efficiency. And you can also plug in the SCOP then, which is given here. SCOP is given as 4.45. And again, that's referenced to EN 14825. So perfect data, nothing to see there. That's all really good. We then have to tell easyPH against what temperature point is that reference. So anyone again familiar with doing BER work or EPC work will be well aware that we use 35-degree test points and 55-degree test points when we're carrying out our BERs. So if you're referencing against 35-degree test data, you select the X on. If you're working against 55-degree data, you select the X off in that case. So you just switch it off there. And then what you can do if you're using the 55-degree data is you then put in the seasonal heating efficiency or the SCOP based on the 55-degree data. And that's all you have to do. PHPP will do all the rest for you. You have no further inputs required, which I think for most people should make it very, very easy to model the heat pump in easyPH. Now we can go a more detailed road. So same as the cooling, we have a detailed approach here that we can use. So we can input our data into our components tab, and then we have a couple of inputs here that we can select from here. So I have entered the EcoAir 17 Pro into the components tab, so we can select that unit from that list, and that's available to us there. If you're using any of the Panasonic certified units, you can just select them directly from the list. There are also, you'll see here some easyPH standard values that you can use. These are fine at the planning stage, but for final certification, you cannot use these standard heat pump values. You must use the real heat pump values. And look, as always on these things, if you're ever in any doubt, contact your certifier, and they'll be usually able to guide you in the right direction if you're having any issues getting data for your heat pump. But I think if you're having issues getting data for a heat pump, in the current market, you probably should be looking at a different heat pump. To be honest, nearly all the manufacturers should be able to provide that. Literally, one email with just an attachment, and you should be done on that front. But we do occasionally see some oddball heat pumps appear in for certification, so it does happen occasionally. So where you decide to go the detailed road, you will go to your components tab, and you will input the characteristics as normal for a heat pump into PHPP. So you'll select what mode it works in. So does it do heating and domestic hot water, only heating, or only domestic hot water? You'll then select the source, which is given then as outdoor air, and you can use groundwater, ground probes, or horizontal ground connector. And then use your heat sink, which in this case is water. If it's air, you select air. So if you're using, say, fan coil units, or sometimes you'll see fan coil radiators and things used. So once you've that done, then you go and put your test points into PHPP. So you'll see all your test points are given, on the data from the manufacturer. We can see here I've entered some of the test points already. So in this case, you can see the T design H, which is the -10 value. As you can see, look, T design H there is -10. And you put in the sink temperature, which is 35, the capacity, which is 3.63 kilowatts, and the COP, which is 2.83. So you need to put in a minimum of 3 test points. We recommend putting in as many as you have available. If you can put up to 8 in, so try and put the 8 in if you can. So you can see here I've plugged in the various test points all along for the system. I'm not going to go through each one. There's no need to. You just, the data is there. You just plug the numbers in. We then have to put in the maximum heating capacity. So we can see from our options here that we can put in at air -20, water 35, air -20, water 55, air -10, water 35, and air -10, water 55. So that will allow us to put in our outputs based on those values. Those are just there to allow PHPP to see where the limits of the heat pump are. So it just allows the calculation to know, when does or is the heat pump adequately sized to deliver the heat and volume for the dwelling. So in that case, what you will do is you'll put in the outputs, and you'll get those from the manufacturer. You usually have to ask the manufacturer to provide those values. But in most cases, you'll actually find that the values are given on the data for the heat pump. So I've actually input those incorrectly. They're actually switched. Right, they should be the other way around. 3.34 there is the correct output for that. So we can see there at air -10 that heat pump can do 3.34 kilowatts. And then in this test point, it can do 3.63 kilowatts. So you input those values there. It then asks you to put in the part load factor. So that's this CDH value here. So what we've tended to do in the past is to put the lowest value that's given on your data sheet here. So the lowest value we can see is 0.96. So that allows for the reduced output as the load reduces, which is your part load factor. So you just put that value in there at that. We then have to put in the on-off limit. Now, there's a lot of confusion about this. So the on-off limit is essentially where the compressor of the heat pump is not able to wind down any further as the output demands go down. So essentially what it's saying is how slow can the compressor go before it has to switch into a fixed speed mode. So most compressors, by the time they get to 30–40% of their design speed, are no longer able to wind down any further, and they have to run at that level as a minimum, in which case they have to switch on and off and go into effectively a fixed speed mode. So typically we put that value in around 40%. You can ask the manufacturer for that. We've had issues getting that value, but if they have it, they can provide it. But 40% covers most heat pumps. And last but not least, you have to put in the crankcase heater and the standby power values, then which are picked up from your data sheet as well. So we can see here on our crankcase heater mode is given to us here. Crankcase heater mode is 9 watts. So we simply type in 9 watts there. That's sometimes given in kilowatts. So you'll need to put in, you need to convert that to watts for entry into PHPP. We also have to put in the standby power, which is this standby mode here. So that's 8 watts in that case. So we plug that value in and we're done with our detailed approach at that point. And that allows us then to switch over from the simplified approach then into the detailed approach. And we just simply select our heat pump and that's the end of it. Job done. Nothing more to see on that then at that point. So that brings us finally on to domestic hot water. So this is kind of we're making good progress now in it. So we've put in our cooling if it exists. We've now put in our space heating, and now we need to put in our domestic hot water. So what we do now is we go back to our data here, and we look up the values for domestic hot water. So we can see here that they've given us domestic hot water profile, which again, anyone working in BERs will be intimately familiar with these, and there's often plenty of tic-tacking and to and fro to get this information from manufacturers. So what you do is essentially you decide again, are you going simplified or are you going detailed proof? Now you can set up separate profiles for heating and domestic hot water within the easyPH calculation. Sometimes there's no need to. You can just simply assign the heat pump directly where you've switched on that the heat pump does heating and domestic hot water, and that essentially is the end of it for your detailed proof of efficiency, because you put in all your test points, so you've got nothing more to enter to cover that. In reality, we tend to find that there's most people will go the simplified method because it's nearly more straightforward in most cases. So again, you have an air to water heat pump, it's an inverter heat pump, all that copies down effectively from above. My apologies here now. So again, make and model, you can have a different one for space heating and for domestic hot water. That wouldn't be unusual. In most cases, that's just copy and paste. And you now have to put the nominal power in, but this has to be the nominal power, and it must be based, again, on it gives some more guidance here, and actually I've inputted the wrong number in there. So again, we put it in at the 35 degrees at -10, which as we'd seen earlier was 3.3 kilowatts. So we input that value there. And then we have to put in our performance values for our heat pump then in domestic hot water mode. So we have a couple of options here. We can take the COP DHW, which is 2.31, and we can plug that in for our SCOP. Again, people are probably screaming at the screen going, but that references the wrong standard. But EN 16147 is again referenced in EN 14825, so therefore that's still valid data for use in this calculation. The alternative is to use the seasonal efficiency of space heating, which I think is a little bit of a misnomer there. That should be correctly the efficiency of domestic hot water, which is 101.1 or 101.4%. So you input that value there. Again, you could, if you don't have that information, you can use the 55-degree data from up here if you wish. There's no problem doing that. I would tend to say try and use the 16147 data if you have it to hand. If not, use the 55-degree data up here to provide those values. And if you have nothing, only 35-degree data, when you're really scraping the bottom of the barrel, then you can put that information in and then put the X to say that you have used 35-degree data, and PHPP will do the rest for you. You have nothing more to do. Same as before for projects in the US, you get the kilo BTUs per kilowatt hour and you put that value in. You're not required to put both values in here. You can put one value in, whichever one you have to hand will be fine. In this case, I plugged in both values, but you're not required to do that. Just be aware with SCOP that must be based on a medium climate. You'll see there's a note there. So irrespective of where the project is located, it's always based on a medium climate. So that's the inputs for domestic hot water. So I think that should be straightforward for most people. And I suppose we're getting down near the end now of the webinar, and we're going to take a look now at entering in domestic hot water. But before we do that, I just want to take a very quick look at boilers. We're seeing less and less boilers being installed in projects these days. There's very few modern projects or new builds been done with gas or oil. It does occasionally arise, so it's only correct that we take a quick look at it. So what you do is you select the type of boiler that you have from the list. You will typically see a condensing gas or a condensing oil boiler. There is also an improved condensing gas and oil boiler. You'll have to look up the PHPP manual for the exact definitions of what they define as just condensing or improved condensing. I can't recall them off the top of my head, but you can look up those values, and then you can simply select your fuel then from the drop down list here. When you select your heat pump, or when you select your boiler, it will give you a fuel option there to suit that. So if you select a gas, it'll allow you to be natural gas, LPG, biogas, whatever. Likewise, if you select oil, you can then select your fuel, then whether it's standard heating oil, bio oil, or methanol. So depending on your type of boiler, you will select your heat source to suit from there. So again, back up the top here, you can assign a heating boiler here and assign the percentage where you have a hybrid arrangement. Wouldn't be unusual to see hybrid arrangements in dwellings. So if that arises, you can model that there quite easily. So the last bit of our webinar then is to take a look at the domestic hot water distribution and the storage and also the space heating distribution. So I'm going to just quickly go to the space heating distribution because it's actually very easy, and there's literally only a single drop down here for most projects. So what it asks us to do is to tell how the space heating is distributed throughout the dwelling. Now you will see a note there, the selection of split units is not relevant. So where you have split units, you don't have to put anything in here. And where you have an air to water system, you select from the drop down list. And it's quite straightforward. It's just underfloor heating, radiators, or supply air heating. If you have a combination, that's perfectly fine. You put the one in that has the highest output. So, if you have, say, underfloor heating in the living room and the kitchen, and then you have radiators everywhere else, and say the underfloor heating does 1/3 and the radiators do 2/3 or whatever of the dwelling, well, then you would select radiators in that case. If the whole, if say 2/3 of the house is done with underfloor and you have a couple of radiators here or there, you will select underfloor heating. So you just select whichever is the most dominant. There's no need to kind of overthink it. Just look, go by the drawings or by the arrangement of the dwelling and just select the appropriate value. In the unlikely event you have pipework outside the thermal envelope for your heating system, you can switch that on here, selecting the X, and then it asks you to input some values for that. Again, I would advocate if we shouldn't have the heating pipework outside the thermal envelope in most cases, so this shouldn't really arise. So that's all you have to do for space heat distribution. So for domestic hot water distribution, I'm sure many people listen to this webinar today will be really delighted to hear the days of having to go and measure all the individual pipes and work out the accumulated length of pipes and all that stuff are very firmly over with easyPH. There's no requirement at all to go measuring pipework. It just doesn't arise in these buildings. You do need to do one or two small measurements, but by comparison to the approach in the past, this is very, very quick. So what we have to do is we have to put in the first thing is the number of stories. So we just simply type in if it's 1, 2, 3, 25, 50, whatever number of stories in the building. We just simply plug in the number there. That's very straightforward. Most dwellings will be 1 to 4 stories. It'll capture 99% of them, I think. That should make it straightforward. The next thing we have to put in is a number of tapping points. So we need to get the domestic hot water plan, or go by the amount of sanitary ware in the houses if there is no plan for it. So what we do is we count up the number of sinks and showers and things like that that have domestic hot water. So in the case of Barry's house here, there was seven domestic hot water tapping points. So we just simply put in 7 number, and that allows us to work out then the calculation from there. So we have to go now and select, and I'm going to blow this up full screen for a moment here on it. So PHPP gives us 4 options here for our type of distribution. So you'll see it gives us 1, 2, 3, and 4, and each one has a different characteristic. So to make life very easy, within the easyPH, there's actually an explanation of each type of domestic hot water arrangement. So you'll see the different types there, and you pick whichever one is most relevant to the dwelling that you're doing. So if you have a very, very tight system, it might be a type 1. If it's a little bit more spread, you might go with a type 2 there, where you have 2 different pipelines. Then where you have a kind of a distribution, but it's not, the pipework lengths are not that long. You would go with medium wide distribution. And then where you have relatively long distances for your domestic hot water pipework, you select distributed widely. So in this case, we select distributed widely because like we could see from the plan here that you have a tap here, you have another tap here, you've got taps over here, etc. Output points. So there's quite a few, quite a bit of pipe work there to bring all those pipes to the various points. So we simply just select from the drop down list, and we've selected distributed widely. So where you have a type 3 or type 4 system, PHPP asks for some further information on that. So you'll see we have 3 measurements that we have to put in here. So the first one is the distance between the longest distance between 2 tapping points on one floor. We have to put in the max building length and the max building width. So we simply go to the plan of the building and we can carry out those measurements. So as you can see here, I've carried out these measurements on the dwelling, and we can see the maximum distance between 2 tapping points is 17.7 meters. We can see that the width of the dwelling here is front to back is 14.1 meters, and the length of the dwelling then is 18.4 meters. So we plug those 3 values in, and we plug that's the end of that. Where you have a circulation system, you can switch that on, and you can put in the insulation thickness for your insulation. That gives us then some further notes there and things like that. So that doesn't arise in most cases in most dwellings. Where you have pipework outside the thermal envelope, again you switch on this box and you input you input the couple of inputs that are required there for that. Again, that shouldn't arise very often in dwellings, particularly single family dwellings. You don't see that very often. And last but not least, we're going to get to domestic hot water storage. So this is an area where we're going to spend a few minutes now before we wrap up, and everybody can go on about their day. So within this section here, we've actually got a couple of different options within the domestic hot water storage. And I think this makes it really easy. It gives us loads of options here. No matter what happens with our design, we should be able to get some option here that works for us. So what we have to do first is define, what kind of storage do we have. So if we have a combined domestic hot water and heating vessel, in other words, if we're using the vessel to provide space heating as well. Now, that's a little bit different from a buffer vessel, because a buffer vessel is designed to protect the heat pump from having to short cycle. Whereas in some cases you'll see that you will have a combined vessel where all the heat will be dumped into a single vessel, and you may have coils coming out with that for space heating or domestic hot water or whatever. They're not unusual. I've come across a few of them. I think Copper Industries make one, and then they have one that generates hot water via really high surface area coil. So if you have a system like that, you select DHW and heating. If it's purely for storage of domestic hot water, you just select DHW only. So that covers the case we had here. So then I ask you, is the tank inside or outside the thermal envelope? It's fairly straightforward. Select from the list, and it asks you to put in the storage volume. So we go to the manufacturer's information. So in this case, Barry had installed a dual cyclone cylinder within his house, and the actual capacity was given on the data sheet by the manufacturer as 495 litres. They simply plug in 495. Now, I would give a slight word of caution here, because we've come across a few instances lately with cylinders where you get a nominal volume and you get an actual volume, and they can be very different. They can vary by sometimes up to 10%, the two values can. So we want to put in the actual storage volume rather than the nominal storage volume. So like if they had given us say a nominal, in this case they've given us a nominal value of 500 and an actual of 495. So we put the actual value in, so we don't put 500, we put 495. But I've seen a case lately where we had a 200 litre cylinder sent into us, and when I actually looked at the real volume of it, it was actually only 178 litres. So that was quite a difference in volume, which was like 12% or something like that, in that order. So you need to always be careful that you're putting the actual volume in there. If you have solar domestic hot water plugged in as well, you can simply switch on that you have that connection. Now, it's important to be careful here, because when we look at this cylinder that Barry installed, it does have dual coils. So it has an actual solar coil in the cylinder, but there's no actual solar domestic hot water generation in the dwelling. So just because the cylinder has it doesn't mean you switch it on. You only switch it on if you actually have a solar domestic hot water system in the dwelling. The mere presence of a coil doesn't serve as evidence, that there's solar DHW. So in this case, we leave that off. And the very last thing we have to do today as part of our webinar is we need to look at the heat losses from that cylinder. So now that we've the volume and the location and all inputted, we now have a couple of options here to allow us to input the heat losses associated with that. So within that, we see we can select automatically, which will give us what I would argue is a terrible result. It's a really, really high amount of heat loss, like 10.18 watts per Kelvin is huge in heat loss terms from cylinders. We can then put in the insulation thickness if we know what that is, and easyPH gives us three options there. So we can put 20 mil, 50 mil, or 100 mil. I'm not sure of the exact thickness of insulation on these cylinders because it just says 0 there. in that box, but I would assume it's probably in around 100. Typically, those cylinders have around 100 millimeters of insulation. So you can select from that drop down. The alternative approach then is to go with the ERP class. So if we have the label for the cylinder, which in this case I did, there was the energy label provided for the cylinder, we can see that the cylinder is a C class cylinder. So in that case, we can select the drop down as, you know, A plus, A, B, C, D, E, F, etc. All very straightforward. Get the label from the manufacturer or from the website or whatever, and just select from the drop down list. And then I suppose there's the most accurate method, which is to put in the actual heat loss rate in for the cylinder. Now we have to be a little careful here. Okay, this is fraught with danger if you're not familiar with the rules around it. PHPP requires that we put in the watts per Kelvin into PHPP, whereas in most cases the manufacturer will give us the heat losses, as they have done here, in kilowatt hours per 24 hours or kilowatt hours per day. Sometimes they'll give it to us just in straight watts. That doesn't matter which format they provide it in, we can convert it to watts per Kelvin. It's actually very easy to do that. So in this case, I have set up a formula up the top here for this. So Joule gave us a value here of 2.76 kilowatt hours per 24 hours. So what I did is first is I converted it into watts. So I took 2.76 and multiplied by 1,000, all very simple. I then had to convert it back into, take out the time factor. So it was per 24 hours, whereas we want the value in watts per Kelvin. So we need to take out the time. So therefore we divide by 24. And then it also gives us the value is in kilowatt hours, and we need to change that back to watts per Kelvin. So what we need to do is we need to divide it by the difference between the storage temperature and the space in which it's installed. So under the European regulations, there's a requirement that the heat loss is calculated on a 45-degree temperature difference, which is 20-degree internal space and 65-degree storage temperature. So we therefore take our 2.76 multiplied by 1,000, we divide that by 24, and we divide it further by 45. That gives us 2.56 watts per Kelvin. So that's our input there into PHPP. And we can actually see there that if we toggle between that and the ERP class, that there's actually not a massive difference between the label result and the calculate result. They're actually both very close, which gives us confidence that that our calculation is accurate. So that's the end of our webinar today on entering heating, cooling, and domestic hot water into easyPH. I suppose I want to take the opportunity here to thank everybody for looking at this webinar. And again, I do apologize for the technical difficulties that we had. And I hope everybody can get an opportunity to have a look at this webinar on YouTube. I suppose there's a lot of thanks due here to Yvonne, Caroline, and Brian from the PHAI. I appreciate that. Barry McCarran likes to be here for some of these webinars, and he doesn't always be able to make it. So hello to Barry as well. And again, thanks to Barry for allowing us to use his dwelling as a guinea pig. And I suppose, Caroline, have you any final words you'd like to say to everybody before we wrap it up?
I suppose, like to thank you, Shane, yet again for giving your time to share all your knowledge. I just let everybody know that we do have a presentation on the 12th of August 2024 on our CPD on the 12th of August with Shane, the final one in the series on certification. But just before we do finish, Shane, a few people did manage to get onto the webinar. There is one question there, if you don't mind.
It's absolutely.
So it says, if we're using a compact heat pump unit like the Pitchler PCOM4 for cooling, we added these details for that to the heat pump section in the components list.
That's a good question. I'm not particularly familiar with the Pitchler PCOM4. I have come across it on my travels, but not to a great degree. But if it has cooling test points and that kind of information available, then absolutely we can enter it into the components tab. and assign it as a cooling approach for our dwelling. So I don't see any problem with that. If the unit is only providing, say, a small little bit of cooling, like just for tempering, you wouldn't include that in PHPP. But if it's actually providing full supply air cooling, then yes, you could enter it into the components tab.
That's great. Thank you very much, Shane.
You're very welcome.
All of Shane's presentations will be available on links on our website. Yvonne will also send them to anybody that's registered to attend the webinar. So thank you to everybody that did manage to get over the technical issues today. And again, thank you to Shane, Yvonne, and Brian. We'll see you next week.